Okay, welcome to Tuesday. It is the 14th, I believe, of April, and this is my second video on the Wilcoxon rank sum test, which is similar to the t-test. We could do it with a z, we just don't want to use that much data, but it's a non-parametric, so it uses ranks instead of the actual data value. Now yesterday, I had a little problem there. I didn't do the ranks correctly, so if you have not watched yesterday's video, you could probably jump right in and do today's. And had I read this, I entered the data in two different lists, but for the Wilcoxon rank sum test, you enter all the data in one list, which is what I didn't do. And that's why on the form that I gave you with the chart on it, there's three columns. A sort column, a group column, and a rank. I actually do them, I do them in sort rank group. You need to put the data and sort it in the first group. These two can be done in either way. So just a quick from yesterday. You should have your HO and your H1. It's a two-tailed test. There it is. But you do not put, now, where am I? Oh, I gotta turn my page. Now, you're gonna not, what I did yesterday, and put them in two different lists. You're gonna follow the note sheet I gave you, and you put all the data in one big list, and then you sort it. Grouping it will help you check that data, but make sure it's nice to check the data before you group it or sort it, because that way you can make sure, go down, check to make sure every data value you put in was correctly, and then sort it. Here's the rankings, and I stayed with the data that I changed. So those numbers, when I posted the those numbers I changed, you're gonna stay with. So here is, these first four numbers should be ranked 1, 2, 3, 4. But because there's 3 4s, you average the ranks and they all get the same rank of 3. Because they're all the same number, they get the same rank. And 3 is in the middle. But then you would pick back up with 5, 6, 7, 8, 9, and then 10, 11, 12 were the same. They're all 12s. 10, 11, 12. The average of those numbers is 11. So they all get a rank of 11, but then you have to remember to pick up. This should have been 10, should have been 11, should have been 12, and then this is a rank of 13. There will not be a rank of 2 or a rank of 4. They share that middle rank, but then you got to pick back up on whatever score that was originally supposed to be. This next score here, this is 9, 10, 11, 12. This should be 13, so make sure that matches. 14, 15, 16, so on, so on, so on, until we get down to 24. That was a rank of, that's the 21st number I put in the list. And then I had two 26s. They should have been ranked 22 and 23. You average those numbers. They both get a rank of 22 and a half. Whoops, that should be a half. And then this goes to a rank of 24. It was supposed to be 22, 23. You pick up with 24, 25, and you know you're good when the last number in the column is the sum of those two ranks. Okay, now, they wanted us to, the next step, let me find my note sheet. We have, here's my note sheet. We have sorted them. We have ranked them. And now we're going to group them. So if you look back at the original data that you had, you just, and I'm finding the original data that I had, for males. I'm finding it. For males, the first prison sentence they had for males was 8. So when I find a data value of 8, I put an M. Then there was a 12, I put an M. Then there was a 6, and I go through and I mark an M. Both of those 12s were males. 22 was a male, 27 was a male, and so on, until you get all the males in. Now, some people put all the males in and say, okay, there's only 2 groups, everybody else must be a female, and they just fill everything in. I use the females to check to make sure my data's right. I go back and make sure the very first female was a 7. I fill them in. I notice that all 3 of the 4s were all female. And I go through the data and put those females in. And if they match up, then I know all my data values are correct and I'm good. Now we're going to go and find the ranks of the smaller class size. N1 must be, and let me write this here, N1 has to be the smaller sample size. And then N2 is going to be the larger. So this is males, this is females. If they both have the same sample size, then you can decide which one you want yourself. So then I went through and I found the ranks of all the males and I just circled them. And I made sure I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers circled. And then I went to my calculator and I put those 12 numbers in there. 5, 7, 11, both 11s, 13, 14, 17, 19, 21, 22 and a half, 24, 26. And then if you go to stat calculate, it was in list 2, there is my sum of the ranks is 190.5. That's my R. The 78 from yesterday was way off because you have to rank the whole group and then sort them out. Now, this is a partner to a z-test. So in a z-test or a t-test, you use the mu, you use the standard deviation. It's just that they're not normal mu's and normal standard deviations or sigmas. They're the average of the ranks and the standard deviation of the ranks. So they have formulas, and these formulas I gave you on the sheet. These were just designed to assimilate, to kind of be similar to the mean and the standard deviation, but using sample sizes instead, because the ranks are dependent on the sample sizes. So here's this is N1 times N1 plus N2 plus 1 divided by 2. And I just threw that in my calculator and I came up with 162. These numbers should be close, fairly close. You know, like yesterday when I got 78 there and I saw that 162, if I would have kept going, I would have noticed it, but I didn't. I was doing grades and, meetings and 14 other things, and that was my fault. Here is my standard deviation. Let me see if I can fold this down a little bit. So here is my 12 times 14, 12 plus 14 plus 1 divided by 12. The entire thing is rooted. So it might be easier to do, I did the numerator, the denominator, and then rooted that quotient. This number ends, so I didn't have to worry about rounding that. That terminated, so I used that one and only decimal place I had. This square roots tend to be irrational, so I went to 4 decimal places. And then I just put them in your typical z-score formula. This is the same. When we did this with normally distributed data, it was x bar minus mu divided by sigma. And then this uses data This is data minus population mean minus population standard deviation. So the ranks replaces the average. So I put those numbers in my z-score formula, and there's my test statistic. I went to 2 decimal places because it's a z-score. We used the same chart that we used before with your alphas. These all came off that z-table that we had way back first semester. This is one of the pieces of first semester that comes back. We're doing a two-tailed test. It's 0.5, so there's your critical value. Here it is on a table. There's our do not reject, and we are supporting. Now, be careful. Before I write my conclusion, I always go back to the question and see what they're asking us, because there's always an ask for the conclusion. Test the claim that there is no difference in the prison sentences received by each gender. So if there's no difference, if you go back to yesterday, no difference is HO. We did not reject HO. So it appears as though there is no difference. And if you look at your table, even though it looks like at the beginning, the smaller prison sentences were females, but you have females at the beginning, you have females in the middle, and you have a couple long prison sentences for females also. And then there's males at the bottom, there's males in the middle, and there's a male up here. So it kind of makes sense that there isn't really that big a difference between a statistically significant difference between prison sentences for men and women. So I'm writing that I am supporting. You can put enough evidence to support the claim that there's no difference in prison sentences based on gender. Here's my diagram, and you're probably looking at it right now and saying, hey, somebody forgot to shade. We always shade from the critical value. And because I'm here in my happy place, there is my do not reject. So please, I apologize again. All your data goes in one list. All the data values in one list. Sort them, rank them, group them. And that's why you have, I should have it right here, data, sort, rank, group. You can do that in any order. Now you may have more spaces than you need. This is a general table that I hand out for all the problems, and all the problems have different numbers, different data, sample sizes. So you may have extra boxes here. If by some chance you need some more boxes, you can add them on. But I think that usually works for just about all of them. Now, what I'd like you to do, this is Tuesday, today and tomorrow, and I will come back on Thursday with my solution to this one. What I would like you to do is try, I am going to post number 6. So please try, and it's on a different page, so I'm going to post it with this video. You're going to try number 6. There is an added piece of data that I put at the end for brand B. There's an extra 42 so that they don't have the same number of, they have different sample sizes. And then next week, we'll do one that has the same sample size. And we will assign certain people the different sample sizes, and we'll try to see what difference it makes. But for this week, we are going to do just different sample sizes and make sure that, whoa, I just hit this. Make sure that N1 is your smaller sample size and N2 is your larger. Okay, enjoy. You have till Thursday. Maybe Friday. Friday morning, I'll post this. You know, whenever my Friday morning is usually like 10 or 11. But sometime Friday morning, this will open up. And then you can compare your 6 to this 6. And I might even do a video of the 6 so that you can see my work and we can go through it. And then next week, We'll take a look at different sample sizes, and there'll be an assignment for you to do. I did finish grades. That's the other thing I was working on, so I was a little stressed yesterday. So check out eSchool. If you have an issue with a grade, if you see something in eSchool that you did, in eSchool that you did and I didn't give you credit for, give me a shot, shoot me an email, and I'll take a look at it. Take care, stay safe, stay healthy. Bye-bye.